In our summarizing of data, I would like to talk a little bit about the function frequency. And that is a pretty slick little function, and what it requires is that you have data that you wish to count up, and you have bins. These bins, for example, in this case, we're going to check the frequency distribution for variable 1 and 2. And the bins are just the numbers 0 through 100. And the way that we can get this, type in a 0 and a 10 and a 20. If we go like 10, 20, and then go down there, let me do it so you can actually see that I did something. If we highlight 10 and 20, and then go to our little black cross in the lower right, drag down, we get these bins. And when we summarize them, they're going to go find out how many values are 0, which there are none, and then those between 1 and 10, 11 and 20, 21 and 30, and so forth, up to 91 to 100 will go right here. So let's try this. Let's do frequency. So it's equal sign frequent, and notice that it has done some code completion here, written out the word frequency, and I'm going to hit the tab key. That gives me an open parenthesis. And then it asks for two things: the data array, which is for variable number 1, and the bins, which are these 0 to 20. Excel's kind enough to cover up the beginning of this, so I'm going to use the same exact bins relationship over here. All right. So frequency data array. Let's come over here, click on the first one, Control-Shift down arrow. Now we don't want to hit we need to continue it. If we look up here, we can see where we are so far. We want to put in a comma because we need to put in the bins array. So let's come up here and copy down there. Now in our formula, we are at the end of the expression. We've done the data array and the bins array, so we're going to close the parenthesis and hit enter. And notice that this came down here, and where is 0 would be any value 0 or less, and where there is 0 here, it's any values greater than 100. So you may have noticed we only marked to this point, but it added the 0 at the end, just in case there was overflow from what we did. So let's try that again. We're going to go equals frequency, and just typing the F isn't enough. We'll go in and add an R, and that gets us the whole thing. Then we hit tab, and then variable 2, and click at the top at B2, Control-Shift down arrow, come up here, hit a comma, and then the bins are going to be right here. Close the parenthesis, hit enter, and it just automatically fills around. Now this is an upgrade for Excel on this function. The function of frequency used to be much more difficult, and I am not going to go in it, but if it doesn't work and it just leaves you with a single number up here when you do this, then you have an older version of Excel, and you need to go into the help and find out how you do frequencies. It's still possible, it's just a little more complicated. Okay, so next we're going to go into a sample data set. And this is a data set that has to do with ortho K lenses, and we have lens type 0 and we have lens type 1. 0 is a spherical lens and 1 is an aspherical lens, And you can see there are a lot of observations here. If we were going to actually do this, it would be time consuming to go through each of the observations. So, and count them or do anything like that. Let's remember the point at which they split its column, or its row. 178 ends 0, 179 begins 1. Now notice I don't know what variable I'm on now. That's very annoying. So another thing that you will want to know is we want to keep track of our lens type, but as we scroll down we'd like to be able to see this top row, and that is done with freeze frames. Freeze frame, you can just do the top row, you can do the first column, but you freeze frames itself keep rows and columns visible while the rest of the worksheet scrolls based on where it is. So we have put our cursor right here, so when we click on freeze frames you can see a faint outline that's there. Now as we go down it maintains the top row question. Same way we come over here, and it will keep that left row column going. This is good. You have to be a little careful sometimes when you're copying stuff because you don't notice that you're not in row 2 when you're starting your columns. Now let's find out the mean age and the standard deviation. Now one of the things we can do for mean lens 0 is we can go equals average of, this is column D, and it's, remember the first row is the lenses, so it's going to start at 2. We want a colon to identify our range, not a comma. That would just give us the first and last value. And then we want the last number in spherical is D178. So that's the average of those values. There we go. And then the standard deviation is similar. It's D2 colon D178. All right? Now that's for lens type 0. This is lens 0 mean, lens 0 SD, lens 1 mean, lens 1 SD. All right, now see how that's sticking over a little bit? We'd rather, because as soon as we start typing in something, that word's going to be chopped off. We don't want that. So if we come up here and see how my cursor has changed shape and I'm between the C and the D, I get here and I double click and it automatically adjusts that column width, adds a little bit of space. If I end up with a big giant column, I come up here, double click, and it brings it down so that it can be read. It doesn't really get more in the way than it has to. You can always adjust things. The other thing that's kind of nice is, you want to know axis is right there. It's the 180 and not the 0.5. Now I know that anyway, but it's handy to get over that. So what we'll do is we're going to highlight all the columns, and we're going to go to home, and then this is left justified, center, right justified. We want to center everything, and now everything's lined up and has no impact on whether things are numbers or characters. Looks fine. Okay, so we want the mean of lens type 1, or the aspheric. Guess I could have labeled them that way. So this is equals average, and now it's D179 colon to 355. And it gives you the end of the little range that it's identified. You want to look for this blue so you can assured that you've probably done it right. Okay, let's do the standard deviation, Stdev. This time we'll add a dot S for sample. Same thing as without the dot S. There's really no reason to add the dot S other than that's the new way Excel does it. The old way may go away sometime, so it's probably not an evil thing to get in the habit of adding the dot S. I'm not going to do that. I'm just going to do Stdev and let it go. Life's too short to waste time clicking letters you don't have to. Okay, so we are at D179 colon, not comma, colon, D355, close parenthesis. Oops, what did I do? Do you know why I got that? Like that? It gave my little nice little formula? Because I forgot the equal sign. Let's put that in there. There we go. All right, now, effect size. Difference between means divided by the standard deviation. So, equals formula. Now, you put the control second. This is the aspheric was the one that is my new lens. Minus spherical mean, close parenthesis. You want to add those parentheses or you'll just divide by the second number and that would make you unhappy with the wrong answer. Divide by the average standard deviation. My average standard deviation. Oh, for Pete's sake. So it's there, you just can't see it. So we will go average of this. Now, I'm not doing a range because I don't, whoops, that's the wrong number anyway. This, oops, let's try that again. Let's move effect size down one so we can see it next time. Okay, so equals parenthesis minus mean divided by average. Now this time I am not going to do a range because I don't want to include this mean, or yeah, I don't want to include this mean in there, so I'm just going to click that number. Now I hit a comma because I only want these two numbers in my average rather than a range. And so the effect size is pretty small. These groups have been matched through a statistical procedure called propensity analysis, and these are all baseline values. So we don't expect a very big effect size with these values, but only matched baseline. When we look at axial length later for testing, we could do something. Now, we could just do this for as long as we wanted to, and we would get the effect size and the means and standard deviations all the way down there. But that's no fun because we want to learn some new stuff. So let's leave those there, but let's come up here and let's highlight this data set. Well, actually, let's go to Insert. We're going to do a pivot table. So we want to insert a pivot. This is some recommended ones. This is a blank one. We want a blank one for now. And then it's asking us for a range. Now it thought I wanted to use that one, but it was wrong. So I'm going to come up here, click right there. You want to include the names of the variables. Don't start at row 2, start at row 1. Go all the way over to the end and down And then notice you can use an external data source too if you have something somewhere else. Now, this you can either put it in a new worksheet or an existing worksheet. I'm going to do a new worksheet because this goes all the way over to column T, and that can get messy trying to find stuff. So I'm going to put it on a new worksheet. And here it is. It's sheet 5. It's got the little pivot table over here, but on the right-hand side, it's got the stuff we want. So what are some of the variables we want? Well, for one thing, we have age. Well, actually, we have a bunch of these up here. Let's go ahead and just do age again anyway. What the heck? Age, sphere, cylinder, axis, KT horizontal, vertical, axis, key value, HVID, pupil size, central corneal thickness, baseline, axial length. I should do these one at a time, but I'm going to do it this way just because I can. Axial length at 1 year, axial length at 2 years, axial length at 3 years post-treatment, 4 years, 5 years. So they either wore this was AL0 is their axial length at baseline. This is after they've worn the Ortho-K for 5 years. Now notice, what did it do? It summed, it started there, what goes all the way across here, adding up these values. Well, we don't really want the sum of everybody's ages, which is almost 4,000 years of students. So let's see. What happens if we go? No. Can we highlight all of these at once? Nope. Well, that kind of stinks. Okay, so the value of the field setting, we want the average. I don't believe I have to do this every time. What's up here? Not really anything that helps us. Okay, average of age, value, average. Okay. Value, average, okay. I can't believe you have to do this for every month. Okay, value, average, okay. Value. Well, this is a pain, but it's easier than doing them one at a time. Had I known this was going to happen, I probably would have done this many. Value. In fact, let's say that's enough. All the rest of them, I am going to remove. 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 As they say, this can be an exercise done at home. Oh, I think I won't delete those. We'll do the average. This is at 1 year. Okay. Come on. Let's remove year 2, year 3. 3, year 4, but for this year, let's do year 5, and it's an average. Okay. Now, so we look here, now rather than the count of all of them, we just have the averages. So mean, age, sphere, cylinder, axis, AL1, and that's the axial length after a year of wearing Ortho-K and after wearing for 5 years. But wouldn't it be nice if we didn't just have the overall average, but what we want is to know what's the average for each lens type. So let's get lens type here, and let's drag it down to rows. And bam, it instantly calculates the average age for each of these guys. All right, now what we want to do is, how about this way? Can I multiply? No, gosh, I can't even group copy them that way either. Okay. How about if I double click? Nothing, huh? How about what's over here? Nope. All right, let's drag age down here. Let's put it by average age. And it's sum, which we don't want. Value, and we have to scroll down a little bit. Standard deviation. See, now we have the average of age, the standard deviation of age. Now we're going to the sphere. So, sphere, let's drag it down. Whoa, put it, whoa, put it. It's gonna go, really? Okay, let's take that back up there for a second. Is there anything I can do about this? I could get rid of that. That got me one more. I can make my, no I can't. Okay, well we can work with this I think. So we come up to sphere, drag it down. Wow. Don't move, thank you. Sphere, sum of sphere, we don't want the sum. Value, standard deviation, okay. Now we have the average of sphere and the standard deviation of sphere. Let's go to cylinder. Okay, right there. Sum of cylinder, we don't want that. Value fields, standard deviation, okay. Cylinder, we have axis, average of axis, sum of axis, no thank you. Value field, standard deviation, okay. Come down here, axial length 1. Glad I didn't do them all. Stick that in there. Sum of AL1. Value. Standard deviation. Okay. AL5. All the way to the bottom. Sum, value, click. Standard deviation, okay. Now, we have the average of age and the standard deviation of age, average of sphere, standard deviation, and so forth. We go all the way across there. Pretty cool. Now, let's figure out effect sizes for these bad boys. So, oops. We have equals average or aspheric minus spheric, close parenthesis, divided by the average of the standard deviation. Close parenthesis, around the function average, hit enter, and there we go. Now, we don't want to copy straight across here because we would overlap that, so let's just go up here, Control C, copy, paste. Now we could do that, and then it turns out that we can't actually do what I was trying to do with the copy. So it has to do with some of the averages. Now, it may actually be easier to, rather than use a pivot table for this particular problem, to just go back to our original means and standard deviations, because that you can copy across. But having said that, we have to calculate each one of these separately like we did the first one. So I'm not going to do that. You get the idea. And I will look to see if I can figure out how to do more copying, but it's not looking good right at the moment, so you'll have to do it this longer way. So either use the pivot table or go back and just calculate the averages, calculate the means, the standard deviations for each group separately without using the pivot table, or go to effect size. So that's that summary. So there you have it. Thank you.